Long before cities, before kings, before writing, humanity lived in a world that could not yet host a pandemic. Small bands of humans moved across vast landscapes. A group might number 20, perhaps 40 at most. They followed migrating animals, seasonal plants, rivers, and the weather. When food thinned, they left. When water dried, they walked. Distance was not a hardship. Distance was survival. In this world, sickness existed, but catastrophe did not. A person might fall ill from an infected wound. A child might die from a parasite carried in water. Occasionally a fever would pass through a camp, but the illness burned out quickly. There were too few bodies, too much space, and too little contact between groups. A disease could not find enough hosts to survive for long. It vanished with the last infected individual. For hundreds of thousands of years, this pattern protected humanity. Predators were the true killers. Cold, hunger, injury, and childbirth claimed more lives than infection ever could. The human immune system evolved slowly under these pressures. It learned to fight bacteria from soil and minor pathogens from animals hunted for meat, but it had never faced a sustained biological assault. There had never been a disease that could follow humans across generations. The world was simply too large. A single band of humans might never meet another for months or years. When encounters happened, they were brief. Trade, conflict, or mating occurred, and then separation returned. Even if one group carried illness, the chain of infection broke almost immediately. Humanity existed in biological isolation. This isolation shaped the earliest human body. Our immune defenses developed for short exposures, not prolonged wars. Fever was enough. Inflammation was enough. Rest and survival of the strongest was enough. There was no evolutionary reason for more complex defenses because no disease demanded them. Then something changed. Around 12,000 years ago, the ice retreated. The climate stabilized. Grasslands spread across regions that had once been harsh and unstable. Wild grains grew thick in valleys and along rivers. Animals gathered where food was predictable. Humans noticed. For the first time, moving constantly was no longer necessary. Some groups delayed their migrations. They returned to the same valleys each year. Temporary camps became seasonal camps. Seasonal camps became permanent dwellings made from mud, stone, and wood. The earth was cleared. Seeds were planted intentionally. Food could now be stored instead of hunted daily. Humanity had discovered agriculture. This moment is often remembered as progress. It allowed population growth, planning, and the beginning of organized society. But biologically, it was the most dangerous decision our species had ever made. because humans had unknowingly built the perfect environment for a new kind of enemy. Permanent settlement meant waste accumulated. Animal remains lay near living areas. Water sources became contaminated. People slept close together night after night. Smoke from fires thickened the air inside huts. Children played in soil mixed with organic decay. For the first time in history, humans lived continuously beside their own refuse. At the same time, animals were changing from prey into neighbors. Wild cattle were captured and bred. Goats were kept inside enclosures. Pigs scavenged near homes. Chickens nested close to sleeping humans. These animals carried their own microbes, organisms that had evolved for thousands of years inside non-human bodies. Now those microbes were exposed to something entirely new, the human body. Each day provided another opportunity for adaptation. A bacterium that once survived only inside a cow's lung might enter a human throat through breath. Most died instantly. Some survived briefly. A very rare few learned to endure. Evolution does not plan, it experiments. With every cough, every bite of shared food, every drop of contaminated water, trillions of microscopic trials occurred. The majority failed. A handful succeeded slightly better than before. And over generations, slight advantages accumulated. The first human villages unknowingly became evolutionary laboratories. Population density increased rapidly. Where once 20 people lived within miles, now hundreds lived within walking distance. Children were born close together in time and space. A pathogen no longer needed to travel far to find another host. It only needed to cross a few breaths in shared air. For the first time, a disease could remain alive indefinitely. But early humans did not recognize what was happening. They had no concept of microbes, infection chains, or immunity. They only saw patterns they could not explain. A cough that lingered, weakness that returned each season, thin bodies despite available food, people who did not recover. They blamed spirits, curses, or the anger of nature. Rituals were performed, fires were lit, bodies were buried farther from homes. Yet the sickness continued because its source lived inside them. This illness did not kill quickly. That was its greatest strength. Fast diseases burn out when hosts die too rapidly, but a slow disease travels quietly. A person could walk, work, and care for children while infected. They breathed near others for months or years. By the time death arrived, the pathogen had already moved on repeatedly. Humanity had created the first sustainable epidemic environment in its history. Archaeologists studying ancient skeletons thousands of years later would notice peculiar damage. Ribs fused, spines collapsed inward, bone tissue eaten slowly over time rather than shattered by trauma. These individuals had not died suddenly. they had deteriorated. Entire settlements showed similar patterns across multiple generations. The disease was no longer an isolated event. It had become part of human life. At this stage, the population of the world was still small enough that extinction remained possible regionally. A valley could lose most of its inhabitants over decades. Children born weak did not survive harsh seasons. Adults unable to work could not gather enough food even in agricultural settings. Villages sometimes disappeared without evidence of violence or disaster. They had simply faded. Yet humans did not abandon settlement. The benefits of stored food and protection outweighed the invisible costs they did not understand. More villages formed, trade routes emerged between them, and with trade came distance-spanning transmission. The disease began its slow journey across continents. What had once required direct animal contact could now pass human to human alone. The pathogen had adapted. Humanity had unknowingly given it time, space, and opportunity to evolve into something unprecedented. For the first time in existence, a disease no longer depended on chance encounters. It depended on us, and humanity had no defenses prepared for a war it did not know had begun. At first, the sickness had no identity because it had no single moment of arrival. There was no day when people woke to discover a plague, no sudden wave of deaths that could be remembered by survivors as a catastrophe. Instead, life changed slowly. Too slowly for anyone living within it to understand. The danger hid inside ordinary time. A hunter coughed during the cold months and never fully recovered. A mother weakened after childbirth and remained frail for years. A child grew thin despite eating daily meals from newly harvested grain. None of these events seemed connected, yet they shared a single origin. The illness had learned patience. Within the body, it settled primarily in the lungs. Breath carried it outward. Every conversation, every shared shelter, every night spent sleeping near family spread microscopic particles into the air. Unlike infections from wounds or contaminated food, this one did not require visible contact. Proximity alone was enough. In early villages, homes were small enclosed spaces. Smoke from fires trapped heat and kept animals calm during cold nights. But the same enclosed air circulated endlessly between occupants. Each breath recycled what another person exhaled minutes before. The pathogen did not need strength. It only needed time. Time it now possessed in abundance. Unlike hunter-gatherer life, settlement created continuity. The same individuals encountered each other every day for years. A disease that could persist quietly within a body could move repeatedly among the same community until nearly all had been exposed. Yet many did not die quickly. That made the threat difficult to perceive. Some developed mild symptoms and survived for years. Others carried infection without obvious illness, but still transmitted it onward. Only a portion deteriorated severely, and even then decline lasted seasons rather than days. The human mind does not easily recognize slow disasters. Without sudden change, patterns remain invisible. But evidence accumulated in the bodies of the dead. In burial grounds from this period, skeletons show signs of prolonged suffering. Vertebrae compressed into angular deformities, ribs pitted from internal inflammation, joints weakened from chronic infection. These individuals had lived long enough for disease to reshape their bones. To their families, the transformation must have been disturbing. A strong adult gradually bending forward, coughing blood into cloth, losing the ability to walk upright. They did not understand contagion, yet they witnessed repetition. The same decline appeared in different people over generations. Communities attempted explanations. Some separated the sick from the healthy, placing sleeping areas at a distance. Others burned aromatic plants in shelters, hoping to purify the air. Certain groups began burial rituals involving deeper graves or stone coverings, perhaps suspecting the dead carried danger. None of these measures consistently worked because the disease moved invisibly before symptoms appeared. Children were especially vulnerable. In small populations, survival of children determined the future. When many failed to reach adulthood, the impact extended beyond families into the stability of entire settlements. Crops required labor. Structures required repair. A village weakened over years could collapse not from sudden tragedy, but gradual inability to maintain itself. Archaeological sites show abandoned dwellings without signs of attack or disaster, storage pits left full, tools left in place. The inhabitants likely dispersed, seeking healthier lands, unknowingly carrying the disease with them. Movement now spread the infection farther than any animal vector had before. Trade intensified this expansion. As agriculture stabilized food production, communities began exchanging goods, stone, shells, pigments, and later metal. Traders traveled between settlements repeatedly. They were welcomed because connection meant survival during poor harvests. Yet every journey linked distant populations, biologically as well as culturally. A cough in one valley could reach another months away. The pathogen benefited from human cooperation. In earlier times, compassion had little effect on disease survival because infections ended quickly. Now, caregiving extended exposure. Families stayed near the sick for weeks or months. They fed them, cleaned them, slept beside them through cold nights. These acts strengthened social bonds, but also sustained transmission chains. Human empathy unintentionally protected the disease from extinction. Over generations, the illness became familiar. Not normal, but expected. Every person had seen its signs. Entire cultures incorporated it into belief systems. Some viewed wasting sickness as spiritual transformation, others as punishment, others as fate tied to certain seasons. The lack of sudden onset prevented unified fear, yet constant presence ensured universal recognition. What no one realized was the scale of danger. Human populations at the dawn of agriculture were still fragile. A few thousand individuals across large regions. A disease that consistently weakened adults and killed children threatened long-term survival more than violent predators ever had. Predators removed individuals. This illness reduced birth success across generations. Had it been slightly more lethal, entire human lineages might have vanished. Instead, it hovered at a precise balance, deadly enough to reshape evolution, not deadly enough to end its own hosts. This balance allowed the pathogen to embed itself deeply into humanity's biological future. The immune system responded slowly across generations rather than within a single life. Those with slight natural resistance survived more often. Their children inherited similar defenses. Over centuries, the human species began adapting without understanding why. The disease was forcing evolution. But adaptation requires time, and during that time suffering dominated daily existence. Early art from settled cultures frequently depicts thin figures, hunched postures, and caretaking scenes. While symbolic, these images may reflect familiar realities of chronic illness. The sick were part of the community rather than rare anomalies. Humanity had entered a new relationship with nature, no longer fighting only external threats like animals or climate. Humans now battled an internal adversary carried within their own breath. The concept of invisible danger began shaping behavior long before scientific reasoning existed. Habits of spacing sleeping areas, ventilating shelters, and avoiding persistent coughs slowly appeared in cultural traditions. These practices were primitive public health measures born from observation rather than knowledge. The disease had not merely infected bodies. It had begun altering behavior, belief, and survival strategies. Civilization itself was adjusting around an unseen opponent, and this was only the beginning. Because the microbe responsible had not finished evolving. As settlements grew larger and trade routes expanded farther, the pathogen would soon gain something even more powerful than proximity: continuity across continents. Thousands of years passed before humanity learned how to read the language of bone. When early agricultural settlements disappeared, the living moved on and memory faded. But beneath soil and stone, the dead remained. Their skeletons preserved the story that no living witness had understood. Centuries later, when modern science uncovered these graves, patterns began to emerge that could not be explained by violence or accident. Many skeletons showed damage concentrated in specific areas: the spine, ribs, and hip joints. The destruction was slow and methodical. Bone tissue appeared eaten away from within, rather than shattered by external force. Vertebrae collapsed forward into permanent curvature, a deformity that would have caused severe pain and difficulty breathing during life. These people had not died suddenly. They had suffered for years. In numerous burial sites across different regions, the same signs appeared repeatedly. Separate communities, separated by distance and time, carried identical skeletal scars. This suggested a shared biological cause. The damage was too consistent to be coincidence and too widespread to be local. Scientists eventually identified the pattern as evidence of a chronic infectious disease. The culprit was a bacterium capable of living inside human lungs and spreading slowly through air. Today it is recognized as tuberculosis, but in ancient times it had no name and no explanation. It was simply a wasting sickness that lingered until strength was gone. Unlike later plagues, it did not announce itself with sudden mass death. Instead, it weakened populations gradually. A person could remain active for months while contagious. The disease advanced quietly, passing from host to host without dramatic outbreaks. This silence made it more dangerous than fast killers. Rapid epidemics reveal themselves. Communities respond with fear, isolation, and avoidance, even without understanding microbes. But a slow infection hides inside normal life. Families continue daily routines. Travelers continue journeys. Children grow beside the sick. The chain of transmission never breaks because no one knows it exists. In early human history, this created the first true persistent epidemic. Archaeological studies show entire generations affected. Some skeletons display early-stage infection, others advanced destruction. The mixture proves that the disease remained present within the same settlement across decades, rather than appearing briefly and disappearing. It had become endemic, a constant companion of humanity. The bacterium thrived in the lungs because breath connected every person. Coughing released microscopic droplets invisible to the eye. In enclosed shelters, these particles lingered in still air long after the sick individual left. Anyone entering the space inhaled them unknowingly. The infection required no wounds, no insects, no contaminated food, only shared air. For early villages built from mud and thatch, ventilation was minimal. Fires burned constantly for cooking and warmth, reducing airflow further. Families slept close together for protection and comfort. Each night, hours of exposure accumulated. The disease exploited intimacy. Children were infected earliest because they remained near caregivers constantly. Many survived initial infection, but carried the bacterium dormant inside their bodies. Years later, during adolescence or adulthood, illness activated and began spreading again. Thus, one generation transmitted to the next without interruption. This pattern created a biological continuity never before experienced by humans. Before settlement, infections either killed quickly or vanished with migrating groups. Now, a disease could remain alive within a community indefinitely. It no longer depended on environmental reservoirs or animal hosts once adapted to humans. Humanity itself became the reservoir. The consequences extended beyond health. Long-term illness reduced productivity. Farming required sustained physical effort. Planting, harvesting, grinding grain, maintaining irrigation. A weakened population produced less food, increasing vulnerability to famine even in fertile regions. Malnutrition further weakened immunity, intensifying disease severity. A cycle formed. Infection caused weakness. Weakness reduced food production. Reduced food worsened infection. Communities struggled to escape this loop without understanding its cause. Some migrated, unknowingly transporting the pathogen to new regions where the cycle began again. Genetic studies indicate the bacterium adapted alongside humans during this period. Strains became specialized for human transmission rather than animal survival. What had once likely originated from cattle evolved into a uniquely human disease capable of sustained spread without animal contact. Human civilization had created a new ecological niche. Dense populations breathing shared air. Within this niche, the pathogen flourished. Interestingly, not everyone succumbed equally. Some individuals showed minimal skeletal damage despite living among heavily infected populations. Their immune systems contained the bacterium effectively. Over generations, these survivors contributed more descendants, slowly increasing resistance within humanity. This evolutionary pressure shaped the future human immune response to airborne pathogens. But during the early phase, adaptation was incomplete. Mortality remained high enough to threaten settlement stability. Villages sometimes shrank dramatically across a few generations. Burial grounds expanded while living areas contracted. No evidence of war, climate catastrophe, or predator attack explained these declines. The enemy was internal and persistent. Anthropologists studying ancient remains noticed children buried more frequently than adults in affected communities. This indicated reduced survival into maturity, a serious threat to long-term population growth. Even small decreases in childhood survival can alter the trajectory of a species when total population numbers are low. Humanity at that time was still fragile. Had multiple such diseases emerged simultaneously, survival might have been impossible. Instead, one dominant chronic infection became the primary evolutionary challenge. It acted not as a sudden extinction event, but as a long filter, removing the most vulnerable individuals gradually across centuries. The silent killer was shaping the species. People living through it could not recognize its scale. To them it was simply part of existence, like aging or winter. Yet their bodies were engaged in a biological conflict spanning generations, a conflict that would determine whether humanity could sustain large populations. The archaeological record shows humanity endured, but only through adaptation bought with suffering. And the story of how the bacterium first crossed into human bodies begins even earlier, with the decision that seemed beneficial at the time, bringing animals inside the boundaries of human life. To understand how this disease nearly ended humanity, scientists had to answer a more difficult question. Where did it come from? Early theories suggested it had always existed in humans. After all, the illness appeared in very ancient skeletons across multiple continents. But deeper analysis revealed subtle differences between strains preserved in old remains. These differences told a story not of permanent companionship, but of a crossing. At some point, the disease had belonged to another species. Genetic comparisons between modern bacteria found in humans and related bacteria living in animals revealed close relationships, especially with pathogens carried by cattle. The similarities were too strong to ignore. The organism infecting early humans had an ancestor adapted to the lungs of large grazing mammals. This meant the sickness was born from contact, not coincidence. Before agriculture, humans hunted animals, but did not live beside them continuously. Encounters were brief. A hunt ended in death for the animal and dispersal for the hunters. Microbes rarely had time to adapt. They entered human bodies occasionally, but failed to spread further because the group soon moved away. Settlement changed that completely. Domesticated cattle slept near homes. They breathed inside enclosed pens. Their waste accumulated near human water sources. Humans milked them, butchered them, cleaned them, and lived surrounded by their exhaled air every day for years. Each breath from animal to human became an opportunity. Most microbes still fail to survive inside the new host. But evolution does not require many successes, only persistence across time. A bacterium capable of tolerating slightly warmer body temperature might last hours instead of minutes inside a human lung. Another mutation might help it resist human immune cells long enough to reproduce once. Each minor advantage increased the probability of transmission to another person. The process was slow, but inevitable. Eventually, a strain gained the ability to move from human to human without returning to the animal. That moment marked the birth of the first true human pandemic disease. The pathogen no longer depended on cattle survival. It depended on human society. Archaeological evidence supports this transition. The earliest skeletal signs appear in regions where domesticated cattle first became common. From there, the disease spread along migration and trade routes, matching early agricultural expansion. The map of farming and the map of infection overlapped. Human progress had carried the illness forward. Unlike many later diseases, this one did not erupt explosively after crossing species. It improved gradually at infecting humans, refining its strategy over generations. Its greatest adaptation was restraint. Killing hosts quickly would isolate it. Keeping them alive while contagious ensured survival. The bacterium evolved to live with humanity rather than simply consume it. But coexistence came at enormous cost. People weakened slowly, lost their ability to perform sustained labor. In early farming societies, each adult represented critical productivity. A single household might rely on only 2 or 3 workers to grow enough food for all members. When one person declined, others faced increased burden. Communities compensated by caring for the sick, yet caregiving increased exposure. The stronger spent longer periods indoors beside infected relatives. Children learned compassion early, but also inhaled infection early. The disease embedded itself not only biologically but socially. Care became transmission. In some settlements, burial patterns show multiple related individuals dying within similar age ranges across consecutive years. This indicates household-level spread. Entire family lines may have ended while neighboring groups survived, creating uneven population patterns without visible conflict. Over time, these losses affected genetic diversity. Small, early human populations already risked losing variation through isolation. Chronic disease intensified this risk by selectively removing individuals lacking certain immune responses. Survivors carried protective genetic traits which gradually became more common. The human immune system was being redesigned. Modern research has identified immune markers associated with resistance to tuberculosis-related bacteria. These markers vary between populations depending on historical exposure duration. Regions with the longest agricultural histories often show higher prevalence of protective variants, evidence of ancient selection pressure. In effect, humanity paid for immunity using generations of lives. While adaptation progressed, the disease continued traveling. Trade networks expanded beyond neighboring villages. Stone tools, ornaments, and food products moved across hundreds of kilometers. With every exchange came breath, and with breath came bacteria. No border existed for a pathogen carried inside lungs. Seasonal gatherings intensified, spread further. Early festivals, trade fairs, and communal rituals brought many groups together briefly before dispersal again. These events unintentionally accelerated transmission across wider territories, ensuring the bacterium reached populations previously untouched. When it arrived in a new community, lacking any partial resistance, consequences were severe. Higher mortality occurred during initial exposure. After several generations, death rates stabilized as survivors passed on resistant traits. This repeating pattern moved across continents, slowly but relentlessly, following the expansion of human settlement itself. Humanity was carrying its own evolutionary challenge wherever it went. Despite suffering, complete collapse never occurred because adaptation kept pace with spread. The bacterium remained dangerous but not universally fatal. This balance allowed both species to survive. However, during the early phases before adaptation strengthened, certain regions likely came dangerously close to losing stable populations. The first known disease capable of threatening human continuity had emerged not through malice of nature, but through intimacy between species. Humans had invited animals into their homes and unknowingly invited their microbes into their future. And the longer humanity lived in growing settlements, the more powerful the disease's influence on evolution would become. The partnership between humans and animals began as a survival advantage. After the end of the last ice age, landscapes changed faster than human habits. Herds shifted routes, forests spread, and seasonal certainty replaced the chaos of glacial climates. Some animals adapted easily to human presence, especially herd animals that already followed leaders and predictable grazing patterns. Humans realized they no longer needed to chase food endlessly if food could remain nearby. Domestication was not a single invention, but a gradual agreement. At first, humans simply tolerated animals near their settlements because they provided predictable hunting. Later, they guided movement, fenced areas, and protected herds from predators. Over generations, animals lost fear while humans lost distance. Eventually, both species shared space continuously. This closeness created an unprecedented biological environment. For hundreds of thousands of years, most microbes had lived within the boundaries of their host species. Each organism evolved within a stable temperature, immune response, and internal chemistry. A bacterium living in a cow's lungs adapted precisely to bovine conditions. Entering a human body was normally fatal to the microbe, but constant proximity changed the rules. In early farming villages, cattle often slept only a few steps from human sleeping areas. During storms, animals were brought inside shelters. Their breath filled enclosed spaces overnight. Dust from dried waste rose into the air and was inhaled repeatedly. Contact was no longer occasional, it was daily and unavoidable. Each exposure functioned as an evolutionary experiment. A microbe entering a human lung might die instantly. Another might survive long enough to divide once before immune defenses destroyed it. Rarely, a mutation allowed slightly improved survival. Over years, then generations, those rare successes accumulated. The microbe slowly adjusted to its new host. Humans never noticed the moment adaptation succeeded. There was no sudden outbreak, no first victim recognizable as the beginning. Instead, symptoms appeared scattered across different individuals in different years. Only in retrospect can the transition be seen clearly. A cattle bacterium became a human pathogen. This transformation required 2 steps. First, the organism needed to survive inside a human long enough to reproduce. Second, it needed to leave that human and infect another without returning to an animal. The second step was the true breakthrough. Once achieved, the disease belonged to humanity. Villages made that second step easy. Air circulated between people more often than between people and animals. Family members shared sleeping spaces nightly. If a bacterium could remain airborne briefly after a cough, it could reach another host within seconds. No bite or blood was necessary. Breath alone connected the population. The pathogen had entered the human network. Ironically, behaviors that strengthened society strengthened transmission. Cooperative living meant shared shelters, communal meals, and caregiving. These actions ensured survival against predators and famine, yet they provided continuous pathways for infection. Social success created biological vulnerability. Agriculture intensified the effect further. Stored grain attracted rodents. Rodents carried their own microbes. Waste accumulation nourished insects. Water sources near settlements stagnated. Multiple species interacted around the same human space, multiplying opportunities for cross-species adaptation. The environment became a permanent mixing ground for microorganisms. Humanity had constructed the first microbial exchange hub, but the lung infection remained the most significant because it required no vector beyond air. Other zoonotic microbes needed bites or contamination. This one needed only presence. It turned the most basic act of life, breathing, into transmission. Communities began noticing strange patterns. Strong adults weakened without injury. Hunters capable of long journeys struggled to walk short distances. The sick often lingered for years rather than days, gradually losing weight. Children who survived infancy sometimes declined later without obvious cause. The illness moved unpredictably yet persistently. Some settlements responded by altering animal management. Archaeological evidence suggests certain communities began separating animal enclosures from sleeping areas. Others improved ventilation openings in structures. These changes were practical observations rather than scientific understanding. People noticed proximity worsened sickness, even if they did not know why. However, separation was rarely complete. Animals remained essential for milk, meat, and labor. Removing them entirely meant risking starvation. Humanity could not abandon domestication, so exposure continued. The disease retained its foothold within the population. Over generations, the bacterium refined its strategy. Killing hosts rapidly would limit spread, so natural selection favored strains, causing slow deterioration. A coughing individual capable of working still interacted with many others daily. The longer symptoms remained mild, the more opportunities existed for transmission. The pathogen evolved toward persistence rather than speed. This strategy nearly guaranteed permanence. Once embedded in multiple settlements, connected by trade and migration, elimination became impossible. Even if one community recovered, contact with another reintroduced infection. The disease moved with people as reliably as language and culture. Human expansion carried the invisible passenger across landscapes. From early farming regions, it spread along rivers, through valleys, and eventually between continents as populations migrated. Wherever agriculture established permanent residence, the illness followed soon after. The connection was so consistent that the presence of skeletal damage often helps archaeologists identify early farming sites. The disease had become a signature of civilization itself. But humanity was not entirely defenseless. Small variations in immune response began determining survival. Individuals whose bodies contained the infection lived longer and produced more children. Those without such resistance often died before raising families. Slowly, the balance shifted. Evolution had begun responding to the betrayal. As generations passed, the relationship between humans and their animals became inseparable from the relationship between humans and disease. Domesticated animals changed daily life in ways early people could not abandon. Milk provided reliable nutrition even when crops failed. Meat could be obtained without dangerous hunts. Hides became clothing, bone became tools, and manure fertilized fields. Survival now depended on keeping animals close, no matter the unseen cost. The illness took advantage of this dependence. Unlike predators or storms, it could not be fought directly. There was no visible attacker to avoid, no season when danger clearly arrived. Instead, the sickness followed routine: feeding animals, cleaning enclosures, sharing air inside shelters at night, these ordinary tasks quietly reinforce transmission again and again. Early communities attempted explanations rooted in observation. Some noticed households with larger herds suffered more frequent sickness. Others believed certain winds carried weakness through villages. A few traditions warned against sleeping in fully enclosed spaces without openings for fresh air. These ideas were fragments of truth, shaped by experience rather than knowledge. But understanding lagged far behind reality. The pathogen had now adapted fully to humans. It no longer required cattle to persist. Even communities with fewer animals still carried infection once introduced. The original source became irrelevant. The disease had become human. This transformation marked a turning point in biological history. For the first time, a microorganism depended primarily on human population density to survive. The more successful humans became at living together, the more stable the pathogen's existence became. Population growth ensured its continuity. As settlements expanded into proto-towns, the effect intensified. Larger populations meant the bacterium no longer risked disappearing between outbreaks. A constant supply of susceptible hosts existed at all times. Infants were born without immunity. Visitors arrived from distant regions. Caravans moved goods across long routes. Each connection reinforced the disease's permanence. It became part of everyday life. Yet its effects were profound. Chronic infection drained energy over months and years. Fields were left partially harvested. Construction slowed. Communities could not easily accumulate surplus resources when many members were weakened. Progress itself advanced more slowly because strength was quietly consumed. The illness shaped economic development without being recognized. Some villages stagnated for generations while others expanded. The difference often lay not in soil quality or climate, but in subtle variations of resistance within the population. Groups that survived repeated exposure gradually gained stronger collective immunity and could sustain larger communities. Thus, the disease indirectly determined which settlements grew into early centers of civilization. Human bodies were changing as well. Individuals who survived infection often developed partial protection against future illness. More importantly, they passed advantageous immune traits to their children. Over centuries, genetic variants that enhanced lung defense and inflammatory response became more common. The cost of this adaptation was suffering. Many never lived long enough to benefit from improved immunity. Their deaths provided the selection pressure shaping future generations. Humanity was undergoing biological refinement through repeated exposure to the same enemy. The pathogen evolved alongside its host. Strains causing excessively rapid death tended to disappear because they limited transmission. Strains allowing prolonged survival spread widely. Over time, the disease reached a balance where it persisted continuously, but rarely eliminated entire populations at once. This equilibrium allowed both species to endure. Yet, during early centuries, the balance was unstable. New regions encountering the illness for the first time experienced greater mortality. Archaeological records show population interruptions where settlements shrank significantly before recovering generations later. These were likely periods when the disease first entered unadapted communities. Migration spread the cycle repeatedly. Groups moving into new territories carried the bacterium unknowingly. When they encountered isolated populations, infection passed to people whose immune systems had never faced it. Losses followed until adaptation began again. Humanity was connected by an invisible biological exchange long before written history. The psychological impact was equally important. Because the disease lingered rather than struck suddenly, societies began valuing caregiving more strongly. Individuals unable to work still required food and shelter for long periods. Communities that cooperated effectively preserved more members, indirectly increasing survival of resistant individuals. Compassion became advantageous. Social bonds strengthened under biological pressure. Burial practices evolved as well. Some cultures began separating graves from living areas more carefully. Others practiced washing or covering bodies before burial. Though rooted in belief, these actions slightly reduced exposure to respiratory fluids, offering minor protection. Behavior was adapting alongside biology. The betrayal by animals had initiated a chain reaction. A microbe crossed species boundaries, adapted to humans, and then reshaped human genetics, culture, and settlement patterns. What began as a survival strategy, domestication, had created the first long-term disease relationship in human history, and humanity could not escape it. Even abandoning animals entirely would not remove the infection now circulating among people themselves. The species had entered a permanent coexistence. The challenge ahead was not avoidance, but endurance. Over time, endurance would lead to transformation. The human immune system would strengthen, societies would change, and the memory of the disease's origin would vanish. But its influence would remain written inside the body. The first silent killer had become part of what it meant to be human. When the disease first established itself within human communities, the species possessed no preparation for it. Human immune systems had evolved to handle short encounters with environmental bacteria, parasites from soil, and occasional infections from hunted animals. These threats were temporary. The body either eliminated them quickly or the host died before widespread transmission occurred. There had never been a need for prolonged internal defense against a pathogen that remained for years. This illness demanded something entirely new. Instead of overwhelming the body immediately, it hid within it. After entering the lungs, the bacterium triggered a reaction meant to contain invaders. Immune cells surrounded the infection, forming small barriers inside tissue. In many cases, this prevented rapid death, but it did not eliminate the threat. The organism remained alive, waiting. This created a dangerous illusion of recovery. A person might survive initial symptoms and appear healthy again. They return to work, family life, and travel. Yet the bacteria remained dormant inside their lungs. Months or even years later, weakness returned. During that period, they could unknowingly infect others. Early humans had no biological memory for such behavior. Without prior exposure across evolutionary time, immune responses were inconsistent. Some bodies reacted too weakly, allowing rapid spread through lung tissue. Others reacted excessively, causing damaging inflammation that destroyed their own breathing capacity. Both outcomes led to death, though at different speeds. Communities could not predict who would survive. In a single household, one individual might recover, while another slowly deteriorated. Age did not guarantee protection. Strength did not ensure resistance. The randomness reinforced beliefs in supernatural causes because no clear pattern existed to observe. Meanwhile, the overall population suffered measurable decline. Children who developed severe infection rarely reached adulthood. Adults who survived remained weakened, reducing their ability to gather food or defend the group. When multiple members of a settlement were ill simultaneously, productivity dropped sharply. Agriculture required sustained effort across seasons, and missed harvest windows meant hunger months later. Malnutrition intensified the problem. A weakened body cannot fight infection effectively. Poor harvests led to limited diets dominated by a single grain. Lack of varied nutrients reduced immune strength, making new infections more severe. The disease and food scarcity amplified each other repeatedly. Some villages entered long cycles of hardship. Archaeological layers show periods where construction halted and living spaces shrank. Tools were repaired rather than replaced. Storage pits contained less surplus. These are signs of a population maintaining survival rather than growing. No visible disaster caused the stagnation. Instead, persistent illness drained collective strength. The danger to humanity during this era was subtle but real. Extinction does not require sudden catastrophe. A species can disappear through slow reduction in successful reproduction. If each generation produces slightly fewer surviving children than the previous one, decline becomes inevitable over centuries. The early disease threatened exactly this pattern in vulnerable regions. Yet people did not abandon settlement entirely. Despite suffering, agriculture still provided more reliable calories than constant migration. Even weakened communities survived more consistently than hunter groups facing unpredictable hunting seasons. The benefits remained greater than the cost, ensuring continued exposure. Humanity was trapped between progress and vulnerability. Some groups attempted relocation, moving to new lands, seeking healthier conditions. For a short time, they improved. Fresh air and distance reduced immediate exposure. But as soon as new settlements formed and populations stabilized, the infection returned, carried by members who had harbored it silently during migration. The disease followed wherever humans built permanence. Interestingly, not all individuals experience severe illness. A small portion naturally contained the bacteria effectively. Their immune systems formed stronger barriers around infection sites, preventing extensive lung damage. These people often lived long enough to raise multiple children. Their advantage shaped the future. Over generations, the frequency of protective immune traits increased within affected populations. This was evolution, operating directly on survival probability. Those unable to resist infection left fewer descendants. Those with partial resistance slowly dominated gene pools. But adaptation required many lifetimes. During the early centuries before resistance spread widely, humanity existed in a precarious balance. Population growth slowed drastically compared to later agricultural expansions. Settlements remained small because they could not sustain larger numbers of healthy adults simultaneously. The world was quiet not only from limited technology, but from biological limitation. There is evidence that some regions experienced near abandonment before recovery generations later. These patterns suggest the disease approached thresholds where human presence nearly vanished locally. Only migration from less affected areas restored population density. In effect, humanity was learning to survive a permanent internal enemy through trial and loss. No individual understood the process. Yet collectively, the species was adapting. Cultural behaviors also began shifting subtly. Greater emphasis on caring for the chronically ill improved survival of partially resistant individuals, preserving their genetic contribution. Social cooperation unintentionally supported biological resilience. The absence of immunity had forced humanity into a long evolutionary apprenticeship, and the lessons were harsh. As the generations continued, humanity lived under a pressure it could neither see nor escape. The illness did not strike with dramatic waves, yet its persistence altered the rhythm of life. Villages planned around weakness. Tasks were distributed not according to skill alone, but according to endurance. Some adults worked intensely during brief periods of strength and then withdrew for weeks as coughing and fatigue returned. To those living through it, sickness was not an event but a condition. Children grew up expecting to witness decline among elders long before old age. Young adults understood that physical strength could fade unpredictably. This awareness shaped behavior. Communities stored more food than necessary when harvests were good, anticipating times when labor would fail. Cooperation became a practical necessity rather than a moral ideal. Yet planning could not solve the deeper threat. The disease targeted the lungs, the organs required for sustained effort. Farming demanded hours of bending, lifting, grinding grain, and carrying water. Individuals with reduced breathing capacity tired quickly. Even a small decrease in average stamina across a settlement meant fewer fields planted and less harvest gathered. This had a compounding effect. Lower food production weakened the next generation. Before they even encountered infection, malnourished children developed weaker immune responses. When exposed, they progressed to severe illness more often. The disease then reduced their ability to contribute labor as adults, continuing the cycle. In some regions, population growth nearly halted for long stretches of time. Archaeological evidence suggests that certain settlements remained similar in size across centuries despite access to fertile land. Normally, agriculture allows rapid expansion. The stagnation indicates biological limitation rather than environmental scarcity. People simply could not maintain enough healthy adults simultaneously to support larger communities. The invisible enemy had imposed a ceiling on civilization. Human groups responded in ways they believed practical. Some altered sleeping arrangements, spacing individuals slightly farther apart. Others increased time spent outdoors during daylight hours. Fires were placed nearer entrances to improve airflow. These adjustments were small, but represented observation guiding behavior. Even without knowledge of bacteria, humanity was experimenting with public health. Care for the sick also changed gradually. Instead of isolating entirely, which risked abandonment, communities sometimes designated specific caretakers who had already survived illness. Though they did not know immunity existed, they noticed survivors fell ill less severely a second time. This practice reduced new exposures among the vulnerable. The earliest form of selective caregiving had appeared. Despite these adaptations, mortality remained significant. Adults in their productive years were lost regularly. Burial grounds expanded at steady rates rather than sudden spikes. This steady loss drained knowledge as well as labor. Skills such as tool-making, farming techniques, and seasonal timing had to be relearned repeatedly by younger generations. Progress slowed because memory was fragile. Yet the species endured because not all individuals were equal in susceptibility. Within each generation, some survived infection with minimal damage. Their lungs healed and they returned to full strength. Over time, their descendants became more common. The balance slowly shifted toward resilience. This shift did not eliminate the disease, but reduced its ability to threaten entire settlements. Mortality decreased gradually. Communities began sustaining slightly larger populations. Surplus food became possible more often. Social complexity increased because more individuals lived long enough to specialize in non-farming roles. In a paradoxical way, the disease helped refine humanity into a species capable of surviving dense populations. Without this long period of pressure, later cities might have collapsed immediately under the weight of infection. Instead, early suffering prepared immune systems across generations. The cost was immense, but the benefit was future stability. By the end of this era, the threat of disappearance had passed. Human populations were still vulnerable, yet no longer on the edge of vanishing from entire regions. Adaptation had progressed enough to maintain continuity. The silent killer remained present, but humanity had learned, biologically and socially, how to live with it. The world before immunity had nearly ended, civilization before it truly began. What followed would not be victory over disease, but coexistence, a balance maintained through inherited resistance, written into the human body itself. By the time early settlements stabilized, a quiet transformation was underway inside every human body. The disease had not disappeared. People still coughed, still weakened, and still died. Yet, survival was becoming more common. Children reached adulthood more often than before. Adults who fell ill recovered with greater frequency. The change was gradual, almost impossible to notice within a single lifetime, but across generations it became undeniable. Humanity was adapting. The immune system does not think, but it learns through inheritance. When individuals possessing slightly better defenses survived infection, they passed those traits to their children. Over many generations, small advantages accumulated. No single mutation saved the species. Instead, thousands of tiny variations altered the outcome. Inside the lungs, the body's response to infection began changing. Originally, immune cells either reacted too weakly or too aggressively. Weak reactions allowed the bacteria to multiply freely. Overreactions damaged lung tissue so severely that breathing became impossible. Both led to death. But gradually, a middle response appeared more often. The body learned containment. Clusters of immune cells surrounded invading bacteria, forming stable structures that trapped infection without destroying surrounding tissue. The pathogen remained alive, but restricted. The person survived, sometimes carrying the bacterium silently for life. This balance protected both host and microbe. What had once been fatal became chronic. From an evolutionary perspective, chronic infection was success. Individuals lived long enough to reproduce, passing on the genetic instructions that enabled containment. The bacterium also survived because the host continued breathing near others. Neither side eliminated the other. A biological compromise emerged. This compromise reshaped the human immune system permanently. Certain genes controlling inflammation became more regulated. Others enhanced detection of airborne bacteria specifically. The lungs developed improved defensive barriers, including more responsive immune signaling when foreign particles entered airways. These changes were subtle but powerful over time. Modern humans still carry these adaptations. They influence susceptibility not only to the ancient disease, but to many respiratory infections. The ability to form localized immune barriers, for example, helps control numerous pathogens before they spread widely. What began as survival against a single enemy became a foundation for broader defense. But adaptation was uneven. Different populations experienced the disease for different lengths of time. Communities exposed earlier developed resistance sooner. Groups encountering the illness later suffered higher mortality until similar adaptations spread among them. Migration continually mixed these variations, distributing protective traits across humanity. This created a global evolutionary exchange. Human history is often described through movement of language, culture, and tools. Yet alongside these visible changes moved invisible genetic adjustments shaped by disease. Every migration carried both the pathogen and the resistance it forced into existence. The long war was fought without awareness. No one recorded it, yet every generation participated. Infants born with slightly stronger defenses were more likely to become parents. Families unknowingly selected for survival simply by living through infection. Over centuries, the species shifted from vulnerability towards stability. The disease remained present, but its power diminished. Instead of threatening entire communities, it became one of many challenges. Individuals still died, but not in numbers capable of halting population growth. Villages expanded into towns. Towns formed networks. Civilization could now progress because the biological foundation had strengthened. Ironically, the pathogen itself had driven this advancement. By forcing adaptation, it prepared humanity for denser living conditions. Without this period of gradual pressure, later urbanization would have faced catastrophic collapse from airborne infections. Instead, the species entered the future partially prepared. Yet the conflict was not truly over. The bacterium continued evolving as well, Strains capable of bypassing improved defenses appeared occasionally, causing renewed suffering. But now humanity possessed a collective advantage, inherited resilience. The balance favored survival more often than extinction. The long war had shifted direction. As resistance slowly increased across generations, something remarkable happened. The disease no longer determined whether humanity could exist. Instead, it began determining how humanity would live. People who survived infection were not always fully cured. Many carried the bacterium silently inside their bodies for decades. It remained contained within small pockets of immune cells, unable to spread but never entirely eliminated. These individuals lived normal lives, worked, raised children, and aged. Yet they carried a dormant threat. This condition changed the meaning of health. Health was no longer the absence of disease. It became the ability to control disease. A person might appear strong while harboring infection that could awaken under stress, hunger, or age. Early humans learned through observation that weakness often followed hardship, not just injury. Periods of famine or cold winters were frequently followed by renewed sickness among survivors. The body required constant balance. Nutrition, rest, and social support became indirectly connected to survival in ways people could sense even without understanding microbes. Communities that shared food more evenly experienced fewer severe outbreaks. Those that abandoned weakened members lost valuable resistance within their population. Cooperation began shaping biological outcomes. The immune system itself was becoming more coordinated. Instead of reacting violently, it developed signaling pathways that managed inflammation carefully. Excessive response could destroy lung tissue faster than bacteria. Controlled response trapped infection without suffocation. Over generations, genetic traits favoring regulated inflammation became more common. This refinement improved survival dramatically. Children born into later agricultural societies had higher chances of reaching adulthood than their distant ancestors. The difference was not due to better medicine or technology. It was written into their biology. Their bodies inherited knowledge encoded through natural selection across countless previous lives. Yet, the pathogen never vanished. Because it did not disappear, it continued influencing human behavior. People noticed that crowded sleeping spaces worsened sickness. They preferred fresh air when possible. Even symbolic rituals, such as smoke cleansing or open-door practices, may have unintentionally improved ventilation and reduced exposure. Cultural habits were shaped by biological memory. Some societies developed traditions of caring for the chronically ill within extended family groups. This preserved individuals who had survived infection and therefore possessed partial resistance. Their presence increased the proportion of resistant genes in the community. Compassion, therefore, strengthened survival prospects. In other words, kindness became evolutionarily useful. The Long War produced not only stronger immune systems, but more cooperative societies. Humans who worked together endured disease better than those who did not. Social bonds became tools of survival as important as physical strength. Population numbers began rising more steadily. With mortality decreasing, settlements expanded beyond previous limits. Surplus food supported specialists, toolmakers, builders, traders. These developments are often attributed solely to agriculture, but stable immunity played a crucial supporting role. Without it, increased density would have reignited collapse. The disease had forced humanity to prepare before growth. Over time, the bacterium reached equilibrium with its host. It persisted widely, but rarely threatened extinction again. Instead, it became a background presence, occasionally deadly, but generally manageable by inherited defenses. However, the legacy remained permanent. The genes selected during this era continued influencing responses to future illnesses. When later airborne diseases appeared, humanity did not face them entirely unprepared. The immune system already possessed mechanisms for containment and regulation, refined during this ancient conflict. Thus, the Long War became a foundation. It demonstrated that survival against invisible enemies required patience measured in generations. Humanity did not defeat the disease through discovery or invention. It endured long enough for its own biology to change. And those changes would echo through every epidemic that followed. Long after the first settlements stabilized and the earliest farmers forgot the origin of their suffering, the consequences remained hidden inside the human body. Every human alive today carries biological evidence of that ancient conflict. The struggle with the first widespread airborne disease did not end when mortality declined. Instead, it became part of human genetics. Traits that once determined survival in early villages continued passing from parent to child, eventually spreading across continents. These traits altered how the immune system detects, contains, and remembers infection. The ancient battle was preserved not in stories, but in DNA. Modern genetic research reveals that certain immune genes show unusually strong signs of natural selection. They changed more rapidly than most of the human genome during the early agricultural period. Such rapid change only occurs when survival depends on it. The strongest pressure came from respiratory pathogens that required long-term containment rather than quick elimination. The immune system learned patience because impatience was fatal. One key adaptation involved how the body builds defensive structures around invading bacteria. Instead of destroying lung tissue through uncontrolled inflammation, specialized immune cells coordinate to isolate infection. This strategy sacrifices a small region of tissue to protect the whole organism. It is a compromise between damage and survival. These containment responses exist in nearly all humans today. Without them, many modern infections would spread uncontrollably through the lungs. The body's ability to form stable barriers against airborne pathogens originated during the long coexistence with that early disease. What once evolved as emergency adaptation became standard defense. Another change affected fever regulation. Early humans often died when the immune system overreacted, producing extreme fevers that weakened them further. Over generations, genetic variants favoring moderated temperature response increased. Fever remained useful, but less likely to become lethal. This balance improved survival not only against the ancient illness, but also against later infections. Breathing itself became better protected. Cells lining the respiratory tract evolved improved detection of harmful particles. They release chemical signals more quickly, alerting the immune system before infection spreads deeply. This early warning system reduces severity even when infection cannot be prevented entirely. These adaptations are universal because they became necessary for survival. Humanity did not consciously develop them. They emerged because individuals lacking them rarely lived long enough to produce descendants. Over centuries, the entire species changed. The average human body became a record of past epidemics. The scars are invisible, yet measurable. Researchers studying modern populations find differences in immune gene frequencies reflecting ancient exposure patterns. Regions where agriculture began earliest often show stronger inherited resistance markers. Areas reached later by the disease historically experienced higher mortality during subsequent epidemics. The past shaped future vulnerability. When new airborne illnesses appeared in recorded history, some populations suffered more severely because their ancestors had encountered the ancient pathogen for fewer generations. Others endured better due to inherited defenses accumulated over millennia. The ancient disease had prepared some societies long before they knew what preparation meant. But adaptation came with trade-offs. An immune system tuned for strong containment can sometimes react too strongly to harmless substances. Modern inflammatory conditions and autoimmune tendencies may partially result from defenses forged in an environment of constant infection. The body remains ready for threats that are less common today. Evolution solves immediate problems, not future comfort. The ancient pathogen demanded vigilance, and the immune system retained that vigilance even after the original danger lessened. Humanity gained survival, but accepted new vulnerabilities as a consequence. These genetic traces confirm that the disease was not a temporary event. It was a defining force in human development. Without it, our immune responses would function differently. Our tolerance to crowded living conditions might be far lower. Later, civilizations might have collapsed repeatedly under infection pressure. The first silent killer became an architect of the species itself. The deeper scientists looked into human genetics, the clearer the pattern became. The ancient disease had not simply selected individuals, it had shaped entire biological systems. Layers of defense that modern humans rely on daily originated during that prolonged confrontation. What people now consider normal immune behavior was once an emergency adaptation. Even the way the body recognizes danger changed. Specialized immune receptors evolved heightened sensitivity to molecules associated with airborne bacteria. These receptors act as alarms, identifying intruders before symptoms appear. When triggered, they coordinate a measured response instead of uncontrolled inflammation. This balance allows survival during repeated exposure. Without such coordination, dense human populations could not exist. Cities depend on tolerance to constant microbial presence. Every breath in a crowded environment carries microorganisms. The human body must evaluate thousands of harmless exposures while reacting decisively to harmful ones. The roots of this selective response trace back to the ancient era when failure meant extinction. Memory became biological rather than personal. Each generation inherited a body prepared by previous generations. Infants were born with immune tendencies shaped by centuries of survival trials. Although individuals still needed exposure to strengthen immunity, the baseline resistance was already present. Humanity no longer began life defenseless. This inheritance transformed disease dynamics. Instead of spreading unchecked, infections encountered partial resistance in most hosts. Transmission chains slowed naturally. Epidemics still occurred, but recovery rates improved. Communities could maintain continuity even while illness circulated. Another consequence appeared in lifespan patterns. As resistance increased, more individuals survived into older adulthood. Knowledge accumulated rather than resetting each generation. Skills improved, agriculture advanced, and early technology developed faster. The growth of culture depended partly on biological stability. The ancient disease indirectly lengthened human memory. Because elders survived longer, traditions persisted, and innovation became possible. Societies no longer rebuilt from near collapse repeatedly. The species had crossed a threshold where survival was reliable enough for progress. Yet the genetic record shows the cost clearly. Segments of DNA related to immune regulation exhibit signs of intense selection pressure over a relatively short evolutionary period. Such pressure indicates high mortality before adaptation stabilized. Many lineages must have ended without leaving descendants. Humanity today is descended from those who endured the pathogen's test. The disease functioned as a filter. Those with inadequate responses vanished gradually from the gene pool. Those capable of containment became ancestors of future populations. Every person alive carries evidence of that selection in the efficiency of their immune reactions. Even modern medical research depends on these inherited defenses. Treatments that support the immune system rely on mechanisms evolved during that ancient struggle. Vaccination works because the body already possesses the capacity to remember and respond more effectively after exposure. The groundwork for this ability formed during long coexistence with persistent infection. The influence extends beyond biology into behavior. Human sensitivity to coughing, avoidance of stale air, and preference for open spaces during illness likely developed from repeated exposure across generations. These instincts operate below conscious reasoning, yet they reflect historical survival advantage. The scars in DNA, therefore, represent both suffering and preparation. Without them, humanity would face every new airborne disease as its ancestors once did, entirely vulnerable. Instead, the species begins each encounter with accumulated resilience. The first known disease nearly ended humanity, but in doing so, it rewrote humanity into a form capable of survival. The legacy remains permanent. By the time written records began, humanity no longer remembered the first great disease as an origin. To ancient civilizations, it was simply part of life, an illness that appeared again and again across generations. Yet, its true influence extended far beyond the era in which it first emerged. The biological defenses shaped during that prehistoric struggle would determine how humanity faced every later epidemic. The past was about to become preparation. As villages grew into cities, population density reached levels early humans had never experienced. Thousands of people now lived within confined walls. Markets, workshops, and crowded housing compressed breathing spaces together. Under these conditions, a species without inherited resistance to airborne infection would have collapsed quickly. But humanity did not collapse. Disease spread, certainly. People still suffered, and deaths remained common. Yet communities recovered instead of disappearing entirely. The immune adaptations forged during the earlier long war prevented total devastation. What had once nearly ended human settlement now allowed survival within far larger populations. The ancient pathogen had trained the species. Later, airborne diseases followed similar pathways of transmission. They relied on breath, proximity, and time. Each new outbreak tested the same defenses: containment, moderated inflammation, and immune memory. Because these mechanisms already existed, humanity faced hardship rather than extinction. Historical epidemics, therefore, appeared catastrophic but survivable. Written accounts describe fevers, coughing sicknesses, and wasting illnesses appearing repeatedly in early civilizations. Although frightening, they rarely erased entire cultures. Some regions declined temporarily, but recovery followed. The difference between survival and disappearance lay in inherited biological resilience. The earliest disease had established the template. Before permanent settlement, humans survived through mobility. Small groups scattered across landscapes avoided danger by distance. After the disease emerged, survival demanded the opposite. People had to remain together long enough for resistance to spread through generations. Cooperation became more than social preference. It became biological necessity. The sick could not simply be abandoned. During hunter life, a severely weakened individual often meant slowing the group and risking everyone. But chronic illness forced a different strategy. Individuals lived for years while infected. Abandoning them repeatedly would remove large portions of the population. Communities that cared for their ill-preserved knowledge, labor, and genetic resistance, caregiving became adaptive behavior. Those who supported weakened members increased collective survival. Over time, this reinforced empathy as a survival trait. Groups that maintained social bonds outlasted those that did not. Compassion, therefore, was not only emotional, it influenced whether descendants existed at all. The disease encouraged stable families. Children required extended protection because infection often appeared later in life. Parents and relatives remained together longer to ensure survival of the next generation. Multi-generational living arrangements became common. Experience from elders guided younger members through seasons of sickness and recovery. Human society deepened. Communication improved as well. Explaining symptoms, warning others, and coordinating care required more complex language and shared understanding. Cooperation extended beyond hunting or farming into health management. Communities began recognizing patterns even without scientific explanation. These behaviors marked early medicine. People experimented with isolation, airflow, warmth, and nutrition to help the sick recover. Some practices worked slightly, reinforcing belief in deliberate treatment rather than pure superstition. Healing roles appeared in societies. Individuals responsible for observing illness and advising others. The origins of healthcare were practical responses to chronic disease. Although they lacked knowledge of microbes, early humans developed habits that reduced spread. Fresh air spaces, burial separation, and avoidance of shared breath during severe sickness emerged gradually. These actions did not eliminate disease, but improved survival enough to matter. Civilization benefited from these changes. With more individuals living longer, knowledge accumulated. Skills were refined rather than rediscovered repeatedly. Art, architecture, and organized agriculture expanded because stable populations supported specialists. The ancient pathogen indirectly allowed complexity by forcing adaptation first. The species had crossed from fragile existence to resilient continuity. Ironically, the same illness that nearly ended humanity had made long-term human society possible. Without surviving it, later population density would have caused catastrophic collapse. Instead, humanity entered history already prepared. The pandemic had not destroyed humanity. It had reshaped it. The first great disease did not end with a cure. There was no discovery, no final recovery, no moment when humanity defeated it. Instead, the relationship changed. Over generations, the balance shifted from vulnerability to endurance, and eventually the illness became only one element within human life rather than a force capable of ending it. But its influence never disappeared. The habits formed during that long struggle remained woven into society. Caring for the weak, protecting children, and preserving elders became standard expectations rather than rare acts. Communities learned that survival depended on collective stability. The individual alone could not outlast the threat, but the group could. Human identity expanded beyond strength. In earlier ages, survival favored the fastest, strongest, or most aggressive. After the age of chronic disease, survival also favored patience, cooperation, and planning. The ability to support others through long periods of weakness became as valuable as physical power. These traits allowed populations to persist through hardship. In this way, the disease altered behavior as deeply as it altered biology. Families structured themselves around shared responsibility, knowledge of seasons, food storage, and caregiving passed carefully between generations. Elders lived long enough to teach because communities protected them even when they could not work. Cultural memory strengthened because survival no longer reset constantly. The growth of civilization followed. Permanent settlements developed into complex societies not only because agriculture provided food, but because immunity provided continuity. Without continuity, progress would repeatedly collapse. With it, humans built systems larger than any individual lifetime. The ancient pathogen had unknowingly created the conditions for history. It also prepared humanity for future encounters. Later, plagues were devastating, yet the species endured each one. Bodies already understood containment, Societies already practiced cooperation during sickness. The earliest pandemic had served as training for all that followed. Humanity never consciously thanked it. Instead, it faded into background existence, eventually becoming one of many illnesses recognized by medicine. Modern science identified the bacterium, named it, and studied its behavior. Treatments were developed long after its evolutionary influence had completed its work. By the time humans understood it, it had already shaped them. The first known disease to nearly end humanity, therefore, holds a paradoxical place in our story. It was both enemy and teacher. It caused suffering across countless generations, yet those generations exist because they endured it. Every human breath today reflects that survival. The lungs that expand and contract, the immune cells that react without overwhelming the body, the social instincts that protect the vulnerable all carry traces of that ancient conflict. Civilization, memory, and cooperation stand partly upon its legacy. Humanity did not defeat the disease. Humanity became compatible with it. And in that compatibility, the species found the stability required to build the world that followed. Long before humans understood bacteria, long before the invention of writing or medicine, a microscopic organism tested whether our species could exist at all. It did not arrive as a dramatic disaster. It arrived as a condition of life. A slow pressure applied across generations, shaping bodies and behavior in ways no individual could perceive. Its memory does not survive in stories because it lasted longer than memory itself. Instead, its record exists in what humanity became. The ability to live together in crowded spaces, to survive repeated exposure to illness, and to care for the weak without collapsing as a population were not inevitable developments. They were earned gradually through endurance measured not in years but in centuries. Every society that followed inherited this preparation. When cities rose, people wondered why they did not vanish immediately under disease. When later plagues struck, survivors rebuilt and life continued. Even before science, humanity possessed a quiet resilience. That resilience began during the era when a single illness nearly prevented civilization from forming at all. The pathogen never intended to create progress. It simply adapted to a new host. Yet survival required humans to adapt in return, and adaptation changed more than immunity. It changed relationships. Families stayed together longer. Communities protected those who could not work. Knowledge passed across generations because enough people lived long enough to teach. Civilization required continuity, and continuity required survival through illness. Modern medicine often frames disease as an enemy to eliminate, and many are. But the earliest great disease forced a different outcome. Humanity did not erase it. Humanity endured it until coexistence became possible. Through that coexistence, bodies gained balance and societies gained stability. We still carry evidence of that ancient struggle. In every crowded marketplace where people share air without immediate catastrophe, in every recovery from respiratory infection, and in every instinct to protect the vulnerable during sickness, echoes remain. The first epidemic taught humanity without words that survival depended not only on strength, but on patience and cooperation. The species that entered that era was fragile and scattered. The species that emerged could build history. The ancient illness nearly ended humanity before humanity truly began. Instead, it transformed a collection of small wandering groups into a population capable of enduring together. It shaped lungs that could contain infection, immune systems that could restrain themselves, and societies that valued care as a necessity rather than a choice. In the end, the first enemy did not define us by the lives it took, but by the kind of survivors it left behind.